Cholera is an acute intestinal infection caused by eating or drinking water contaminated with the bacterium Vibrio cholerae. Vibrio cholerae produces a toxin that is made of 6 protein subunits. Vibrio cholerae binds to receptors on cells in the wall of the small intestine and activates cyclic AMP, a messenger molecule, increasing the number of cyclic AMP molecules in the cell. A cystic fibrosis transmembrane conductance regulator, or CFTR, channels are activated by cyclic AMP. The increased concentration of cyclic AMP caused the CFTR channel to open and stay open. This means that chloride ions move out of the cell into the lumen, the inside of the small intestine too. Sodium ions are attracted to the negative chloride ions, so they also leave the cell. With more ions in the lumen has a lower water potential. This makes water leave the cells lining the lumen by osmosis. The cells lose an exceeding amount of water, which causes severe dehydration, and the increase of water in the small intestine causes water diarrhea and vomiting.
3 to 5 million people are affected each year. 100,000 people die from cholera each year. 40 billion hours are wasted collecting clean water. Cholera is common in places with poor sanitation, overcrowding, poor hygiene, war, and famine, such as Haiti, DRC, Somalia, the United Republic of Tanzania, and Yemen. Common sources include contaminated municipal water supplies, food and drinks sold by vendors, vegetables grown with water containing human waste.
People affected by cholera include malnourished children and those with low immunity or HIV.
Symptoms include rapid heart rate, loss of skin elasticity, dry mucous membranes, low blood pressure, diarrhea, and thirst. Vaccines against cholera may not protect up to half the people who receive it, and it only lasts a few months.
Water enters and is forced through narrow fibers under high pressure. Textile mesh traps large particles and parasites. Polyester textile filter traps smaller bacterial clusters. Iodine in resin bead filter kills bacteria, parasites, and viruses. Granulated active carbon removes iodine smell. Clean water exits through tiny pores in the walls of the hollow fibers. Filtered water is safe to drink.
Implications. Social implications include the availability of clean water that can motivate parents to send their children to school. Community, family, and school lifestyles develop a unified and healthy community. Environmental implications include the fact that these straws are made out of durable plastic or carbon, which is recyclable. However, the life straw could be made from bioplastic to increase sustainability. Economical implications include a contribution to economic development of the community through increased productivity of workers and income saved from avoidance of clinic expenditures. Straw is unaffordable for communities and LEDCs. However, LifeStraw donates products to LEDCs with every purchase. Political implications include the fact that LEDC governments must be willing to supply desperate communities that cannot afford it. Donating LifeStraws to LEDCs can be interpreted as foreign aid, which is often not well received.